On Monday we looked at converting coordinates from polar to rectangular, rectangular to polar, and we used these equations down here. Well, we're going to use them still to convert equations from rectangular to polar or polar to rectangular. I think going from rectangular to polar is easier to understand with quotations, than going from polar to rectangular. So we're going to start out with the rectangular to polar. This first one right here. What your goal is, I guess what you should be thinking is, I don't want x's and y's, I want thetas and r's. Okay, I want radiuses and angles. I don't want x's and y's. And after we're finished, we're going to write it in a form that's familiar to us. And so when you write it into polar form, you always are going to finish your problem by solving for r. So you're going to get r alone. That way you could plug it into a graphing calculator if you wanted to. Alright, so we have x and we have y. We know what x is. X is r cosine theta. And y is r sine theta. That equals 5. Okay, to solve for r, all you gotta do is factor r out. So we have the r in front times cosine theta plus sine theta. That equals 5. Now, how do I get the r alone? 5. So you're gonna have r equals 5 divided by cosine theta sine theta. And we do that because r is multiplying to this, and so you just have to divide both sides by that. R is alone, you're done. There's your polar equation. Now, let's get to the more fun ones. This next one.
That's it.
So for this next one, we can do the same thing. Alright, we go r cosine theta minus 1 plus r sine theta squared. Oh yeah, don't forget the squared equals 1. But like I said before, we want to try to get the r alone. We want to solve for r. So you're first going to have to get rid of those exponents, which stinks right here because there's a subtraction sign inside of this, which means we're going to have to FOIL. So when we FOIL this, we're going to get r squared cosine squared theta. Then you're going to get minus r cosine theta, and then minus r cosine theta, which those simplify. You can add those together because they're like terms. And then the last one's going to be plus 1. This one's a lot nicer because there's no adding or subtracting with it. So it's just plus r squared sine squared theta. That equals 1. Okay, now trying to get the r alone. Right now, almost all of these terms right here have an r, except for this guy. So we're going to get rid of him and put him on the other side. And at the same time, I'm going to combine these two terms together. So I have a negative r cosine theta and another negative r cosine theta, which means I have two. Negative 2 r cosine theta. So I go r squared cosine squared theta minus 2 r cosine theta. So that guy got that guy, got that guy. This guy I'm subtracting from both sides, and so now there's no more 1 over here, there's a 0. Okay, then we have plus r squared sine squared theta equals 0. Okay, you guys still with me? Okay, that's a lot of manipulation here. We're doing algebra stuff, algebra concepts that you guys know. Now the next thing I'm going to do isn't something that you can readily see right away. You get trained to do this. You guys see how there's a cosine theta and a sine, or cosine squared theta and a sine squared theta? If those are adding together, what do they equal? 1. Well, actually, they are kind of adding together. See, there's a plus sign right here. Okay, but the problem is that there's an r squared with them both. So we can take that r squared away from both of them at the same time if we put them next to each other. So it looks like this. R squared cosine squared theta plus r squared sine squared theta. Then I have a minus 2 r cosine theta. So I just changed the order here. I put this guy over here right next to the cosine squared theta so that... Did I write something wrong? Oh, yes. Thank you for looking out. I was thinking ahead, I guess. What can I take out of both of these guys?
R squared.
Yeah, if I take an r squared out of both of those, I'm left with cosine squared theta plus sine squared theta. And what does that equal?
1.
Oh, that's so beautiful. Peace out. And so I'm left with r squared minus 2r cosine theta equals 0. So now what the next thing you're going to do is, we're trying to solve for r, remember? So solving for r, we're going to factor out an r here. If we write this in factored form, we can use the 0 property to find out what r equals. You set this equal to 0, you set this equal to 0. Oops, forgot a parenthesis there. So if I set both of those equal to 0, I have r equals 0 and r minus 2 cosine theta equals 0. This one, this r is already solved for. This r I can solve for by adding 2 cosine theta to both sides. So I have r equals 2 cosine theta. So we have two equations. Which equation is the answer? Well, this one right here is just a line with the radius of 0. And that just means it's a dot, it's a point at the origin. Now, when we're talking about polar graphs, they don't say origin, you say pole. If you guys ever see the word pole, it's just talking about the origin. Okay, now this right here is inside of that equation. So we don't need this one. It's kind of being redundant. So this is all you need. That's your answer for that one.